All right, here we are. We're starting week 5, last call for homework. So now, this puts us right now. I edited all that out. We don't care about the homework. We care about new information. And we have new information right now. And that's this Excel function right here, our new one. And from this point forward, including quiz 2, I can't imagine we're no longer using the Z-chart. Which means on quiz 2, no Z-chart, I think. I better not put that in stone, but I think.
What about these problems?
There'll be these problems, but you can't use the Z-chart. You can't use the Z-chart. You're even going to be asked to solve it manually, but when we get to that point where you find out what that Z is, like that negative 0.15 there, or what's it down here, 0.20833, you're not done. But you don't go to the Z-chart. From this point on, you got to use this. Norm S distribution. The difference is that S right there in the middle. Look at the top of the spreadsheet I posted last week in last week's module and this week. Hang on, where is it? Right there at the top. Norm S distribution. I want to tell you, you can put dots on either side. Yes, it's the same thing. Let me put the dots in. Same exact thing, just dots. And what goes in there, in those parentheses, are now whatever you calculate Z to be. Let me go back to that homework again. Let me show you the Z we calculated. Where is it? Right here? So that Z right there, that 0.208333, we got to go 4 digits, so 0.2083. That's what goes in the parentheses. And if this question is or more, you're still putting that number in the parentheses, but you put a 1 minus in front. Right there, right between the equal sign and the norm S distribution, you put 1 minus. If it's an or more.
Where do we put 1 minus?
Right in front of the word.
The word, yeah.
But
Just
on the right
just like
equal.
before.
I'm sorry?
Isn't it like before? Like the binom? 1 minus binom.
Oh, just like it,
Yeah.
on an or more question. Same exact way, 1 minus, right after the equal sign. If it's an or more, that's all you gotta do. Now this is only replacing using the Z chart. So I wanna make sure you understand, notice there's nothing about a Z chart when we're using, where's my, right here, norm distribution like we did on this problem right here and norm distribution on this one. That's completely separate. There's no Z chart involved. It's doing everything for you. It goes straight to giving you the answer. You don't have to use a Z chart or norm S. It's if the problem says to manually calculate. See where I took 30.2 minus 32 down here and 34.5 minus 34.2 down here? When you're being asked to manually calculate it, I believe it's on the homework even, it's then going to say now use norm S, no, not this week, next week. Norm S distribution to find the probability. Do not use the Z chart. That's the difference between now and the future. But then after that, we're not even going to be manually calculating coming up in the far future. And we're only going to be using norm distribution. We probably won't even hardly use norm S anymore after the second quiz. This norm S, again, is just to replace using the Z chart. That's all we're doing with it. Not calculate. We still got to manually calculate that Z, the negative 0.15 in that problem and the 0.2083. Michael, did you have a question? Somebody did. Somebody had their hand up? Go ahead.
I was going to ask if we have to put 4 decimal points or if we norm S distribution.
Yeah, are you talking about like the 0.20833, like that? Yeah, go 4 to the right. And that's what you're putting in here. You can go as many as you want, but don't go less than 4, except for like the top one is negative 0.15. There are no more digits to the right. So that was just coincidence. So let's try it out. You ready? This first one is negative 0.15. So we're going to use norms S. Let's try it right out right here on this spreadsheet. Equals NORM. Do we want dots or no dots? No dots? Let's try it. S DIST parentheses negative 0.15. Now before I hit enter, let's look at what it was on the homework. It came out to, well, I'm using the Excel one, right? Because this one's more exact. Oh, they're the same answer. 0.4404. right? If we did it right, we should get about a little over 44%. So let me open it up, go back here. So I use NORMSDIST distribution, and I put what we just manually calculated, that Z of negative 0.15. So here we go. There it is, 0.440382, just like using Excel. All we're doing is replacing the Z chart. The other homework problem, someone look up what it is, equals norm SDIST, it was 0. Say it again. 21? Oh, take me farther. No, give me all the digits. 20 is 20.
2083?
83.
Or was it 2803?
2083. There's more digits, but we'll go with 4 because you guys are gonna stop at 4, I'm guessing. So here I go. Does that sound right? And if we're correct, the answer should be, I gotta look now because I can't remember that. 0.58, so 58, a little more than 58%. 58.25% if we did it right. Here we go. There it is, 0.5825. Again, we still are manually calculating Z, but now we're not gonna look at the positive or negative Z chart. We're gonna use the NORMSDIST distribution. That's all it's replacing. So that was that one. Hang on, coming back, gentlemen. This is the norm distribution. Now this one is replacing the whole equation. The whole thing, we're not doing it manually at all. That's replacing the whole equation. Just that was on your homework. Go ahead with your question though.
So, I put on the Excel sheet, 0.21 instead of putting the 4 digits. But I got 0.5831. Is that it?
I almost have you. You said on the Excel sheet, right there, you said you put in 0.01, you rounded it? No, we gotta go, now that we're not using the Z chart, we only had rounded it to 0.21 because we were using the Z chart. Now we gotta go at least 4 digits to the right. Unless the calculation doesn't allow you to go past 4 digits, but we gotta go 4 digits to the right. We're trying to get more exact answers now. All right, so can everybody use NORMSDIST distribution? If I said manually calculate Z, you now know how to enter it in there, and you're no longer using the Z chart. Everybody got it? Okay. We learned normal distribution on Tuesday, and it was on your homework, and you did 2 problems with it. But we have not learned NORMINV. NORMINV. Matter of fact, here's the problem I want to talk about. Whoa. Right here. Now, I said on Tuesday, I talked about matter of fact, let me refresh your memory because I did open that up. Talked about Pepzone and their oil inventory control, calculating the probability of running out, losing the sale to the customer because the reorder point was at 20. Matter of fact, the mean was 15 gallons they sell during the lead time, hypothetical lead time, maybe 3 days. They usually sell about 15 of those gallons of oil with a standard deviation of 6. Reorder point set at 20. We did the calculation and we found out, let's see, what did we find out? That there was about 20, just a little more than 20% chance that we would sell more than 20 during the lead time, which means the customer would not be able to buy it from us. They would walk out, drive a quarter of a mile down the road to the other auto supply place, and they would buy it there, losing the customer. And I want to tell you, this is a perfect business philosophy. Businesses always focus on the inventory items that they feel they would lose the sale to a customer. Because what happens is, when they pinpoint the inventory items they would not lose the sale to the customer, they decrease the reorder point. I want to let you know that this strategy takes place. If you've ever gone somewhere and they're out of something, usually it's because they purposely ran out. Because they determined that this is something that most people would not buy because of the inconvenience of wherever they have to go to get it. That's when you're not going to lose it to a customer, to a competitor in most cases. So they'll lower it. But in this case, 20% would be too high. We find out that this is something that could be sold by our competitor right down the road, and we don't want to lose the sale. So we want to lower it to 5%. And I said to you, I'm not going to put on the quiz how to manually calculate what that inventory level should be raised to. I said right now the inventory level, the reorder point, is 20, but we calculated it, we went ahead and went over it, what it needs to be raised to lower that percent chance of running out to 5%. So that instead of a 20% chance of losing that customer and running out, we want to lower it to 5% chance. And I just want to refresh your memory. Again, let me jump forward to it. We had to look up the opposite of 5%. On the Z chart to the left would be 95%. So we looked on the Z chart and we got a Z of 1.645. I'm just kind of pointing some 1.645 would what it have to be equal to. Our standard deviation was 6. We don't know our reorder points, not 20 more, minus the mean of 15. You would use algebra to do that to figure out what that new reorder point would be. But I'm not going to make you use algebra to do that. Instead, though, I do want you to understand how easy it is to use Excel to answer a question like, what does the reorder point need to be raised to only have a 5% chance of losing sales to a competitor because you're going to run out during the lead time. And it's right there. I got it highlighted, so let's look up here. What's happening here is the first number in the parentheses for NORMINV, NORM.INV does the same thing, but NORMINV. And the first number is the percent you would be looking up on a Z chart to the left. Because our question happens to be a more than, ours is to the right. Let me make sure you understand what I mean. What's the probability of us selling more than 20? Is that more than? Or is that less than? More than? That's more than?
Yeah, it's more than.
More than
More
20.
than 20? Whereas it should be like this. Whoops, hang on.
No, that's less than.
That's 20 is more than.
This is it then? Yep.
Yeah.
Okay, more than 20. So that's why we gotta go, okay, it's a 20% chance. Because right here, 15, add 6, 21. So 20 is like right there. And to the right is 20%. This is 80%. We need to get to where to the right is only 5%. And so when we looked on the Z chart, what Z would be, let's see, this is 1.645. So this is 1, this is 2, 645. Right there is what, when we looked on the Z chart. But I don't want you to have to go through, okay, what's the opposite of 5%? You know, looking on the Z chart. But what you gotta do on this Excel function is you do gotta put the percentage. If the goal is to not run out, to not sell more than 20 of them, is 5% chance. Selling that number and less would be the opposite of 5%, which is 95%. So that would have to be 95% in the front. The second number is the mean. The third number is the standard deviation. So what it does is if you know the mean and standard deviation of any thing, you can find the reorder point by determining what percent chance of risk you want to take of running out. You ready? I just came across something, it's these duck calls. We're not selling a lot of them. Matter of fact, nobody's selling these duck calls within a 20-mile radius. What percent should I put for that first digit? By the way, these duck calls in this case, I gotta copy and paste this. Hang on. I don't want to lose these numbers. Hang on. Let me just go here. Let me go here. You ready? What's the average price average amount of duck calls we sell during the order lead time? Did I just get rid of the comma by accident? Let's say we usually sell 10 of them because the lead time is like a week or something. With a standard deviation of really only a standard deviation of about 3. Are you ready? Now, you're the manager. You have these numbers because the past has all been done for you. You've gotten the analysis. You know what the average amount of items you sell during a lead time for every item you have in inventory and the standard deviation. You have to come up though with the percent chance you're willing to take the risk for each of these items based on your knowledge of whether you would lose the sell to a competitor or not if you ran out. These duck calls, based on the description I gave, I'm trying to lead you into thinking that you would not lose it to a competitor. Do you get it? So in that case, what percent would you put as that first number? Now think about it. We are saying that go ahead. Saying 80%. He's saying he's willing to take a 20% chance of running out.
10, 3, 0.
Oh, you didn't say 80?
3, 0.
He said 30.
30%. You're willing to take a 70% chance of running out then. You're saying, let's just run out 70% of the time.
You said within 20 mile radius.
Yeah, I did, but wow. I mean, you gotta show a little love. Wow. I'm not coming to yours, I'm moving because of that policy, that's awful. You'd never have any in stock. Wow. All right, let's try it though. Oh, what do you think the reorder point's gonna be? It's not gonna be 10. 10 would be 50% chance, right? Because 10 is our mean. So we gotta be below, what is our, take a guess our reorder point? What, we're going with,
7.
70% chance, 30%, he's taking it all the way down to 7. Well, what's our mean, 10? I'm going lower than 7.
Why?
5.
Because he's saying only 30% chance to the left and 70 to the right. So 30%, you're right, I guess that would be closer up here. Let's try it. 7, I'm gonna go 6 or less. It's only $1.
Okay, I got you. It's alright.
And I'll put you on
I'll
credit.
let it pass.
Well, I forgot what I'm putting here, 30? You ready? Is it 7, is it 6, is it lower?
6.
Oh, it's 8.
It's 8.
Wow, didn't go as low as we thought at all. You would've won them. You get 7 and
We took it
higher.
too far.
2 for what?
We took it too far.
Yeah, we did. So now the reorder point would be 8. That's right, you wanna lower the reorder point, cause there's the chance of you losing that customer or competitor when the next duck call that you're not even selling that many of down the road. This is what you're doing as a manager. You keep adjusting the reorder points based on the changes of what's going on. But you gotta be familiar with every item that's in your location that you're managing. And you gotta make these decisions. It's all about the reorder point. And by the way, usually each company will train you on the software they use to come up with the reorder points, and it's a lot easier than what we're doing. It does the statistics for you. It's just a matter of you, and you'll get so used to it. If you're managing inventory of any kind, and a lot of you are gonna be managing people, or processes, information, or production, or making things. So in that case, there's gonna be inventory involved in a lot of that, so you're gonna get so used to it that you're gonna be adjusting reorder points without having to do any math. That's how comfortable you're gonna be. Oh, look, let's just go up on a reorder point. No, let's go down to, go up to, that kind of thing. Go ahead.
So is this saying that there'll be a 30% chance that we sell 8 during the lead time?
Or less, 8 or less, that we won't run out. That's saying we won't run out at 8, 30% chance. But it's saying that there's a 70% chance we're gonna sell 8.4 or more. And so there's a 70% chance we'll run out, because we're reordering at 8, and if we sell 9, we're out. That 9th person isn't getting it, because we reordered at 8, and we only had 8 left. If we sold 10, 2 people are walking out of here without it, and we have to give them the whole story. Here's a little slip of paper, I know, here, you can get it at that price, when you come back, blah, blah, blah. Right? Anybody know what I'm talking about? You ever go and get a slip of paper because they ran out and you come back? I wanna tell you who's notorious for purposely changing their numbers based on statistics, and that's airlines. Airlines are notorious for overselling flights on purpose. They do it on purpose because if you do the math on it, they save so much money filling up a plane and having to give somebody a free round trip ticket or whatever they offer because they overbooked to get somebody off that flight. They save a ton of money offering whatever they have to offer to get someone off a flight compared to not having that flight full. That's how, especially with fuel costs the way they are. So if you ever, I can't tell you, when I worked for the consulting firm, I was flying 2 to 3 times every single week. And I can't tell you how many flights I went ahead and got bumped off because the offer couldn't be refused. I mean, there was one time where I had a hotel room, I had free dinner, had breakfast the next day, plus a free round trip ticket I ended up never using, but it was a good deal, I couldn't pass up, right? They kept coming on the plane because no one would get off and kept upping the offer. So know that they do that. You're all gonna be in the business world and sometimes you're gonna have to fly. Know that they'll up the offer if no one refuses and give it some time. All right, let's try another one real quick. You ready? What's gonna happen if I said I want a 50% chance of running out? What will be the reorder point? 50% chance to run out. What's the mean reorder point right now on this, right where my pointer is? 10. So if I put 50% chance of running out, 50% chance of not running out, what will be my reorder point? There you go. Very good. You get it? All right. Any questions? I can't decide whether we should have this on a quiz or not.
We shouldn't.
You think so?
It's too easy.
It is easy? Oh, shouldn't. I thought you said should. This is too easy? Is that true? Is this too easy? I tell you what, a lot of people forget things as soon as they walk out of here, and this is usually one of them right here. All right, what's next on our agenda here? Week 5 instructions have 2 assignments this week that are due a week from today and Thursday. Here's the written assignment and an Excel assignment. I want to make sure you realize, I can't remember the point distribution exactly, but I can tell you that far more points on the Excel part of this week's assignment compared to the written. Right? If I had to guess, I think it's 70% of the points are on the Excel and 30% are on the written. So the focus of Thursday's lecture is about how to do that Excel. Today's going to be about the written part. Let me just show you both assignments so you know what you have in front of you. The written part is going to be from the book. Wow, what's this all about? From the book. Chapter 2, page 40-41, number 1, A and B only. All right, just A and B. Number 3, just A only. Go 4 digits to the right. And then 5, A only. I want to show you them real quick. If you guys have an old edition, this is the perfect time to take a picture of this page so you can make sure the words and the numbers haven't changed from the old edition to the new edition. Yes?
You attach it with the homework?
It is posted. Oh yeah, this picture is posted. I forgot about that. On Canvas. It is posted on Canvas already. So I forgot. So you don't have to take a picture. Let me zoom in though. We're doing, I forgot what number again. 1?
1, 3, and 5.
1, 3, and 4?
5.
5. 1, 3, 5. Number 1, gotta zoom in even more. Hang on, let me make it even bigger. So here it is. There's 5 ratings there, and here are the frequencies, and it's asking you to turn it into, let's see, how many rookies, 4 or better? How many rookies receive a rating or 2 or worse? Oh, you just gotta answer these questions by figuring out which numbers you're adding together. I don't wanna tell you how to do this because I'm about to do an example that's gonna show you how easy this is. And I don't wanna give it away because homework's only taking you 15 minutes and I gotta, did I just record that? Darn, shoot. And I gotta make it harder. 3, look at number 3. Again, Monday through Sunday, you have these different frequencies there. And A says construct a relative frequency distribution. I'm gonna review that real quick, because that was like from 2 weeks ago, maybe 3. But you've gotta construct a relative frequency chart, distribution table from these numbers here, and I'm gonna review that. Number 5. Now this 5, what's different is you gotta work this backwards. You have the relative frequencies. It's asking you to show your calculations to turn it into frequencies. You gotta work this one backwards, show your work, every calculation. So you got 4 of them there, and just to convert those 4 numbers right there, those 4 relative frequencies back into frequencies. Here's my hint. It gives you the total right there where my pointer's going back and forth. There's my hint. See it? 3,057. That's the key to this problem right there. 3,057 is the key to this problem. All right, so there's those. Now let's go to the Excel, just so you can see what you have coming up, what we're going to talk about heavily on Thursday. Here it is. You have all these numbers over here, and I think it goes farther to the right. So when you start figuring out what cell locations to use for this data, make sure you realize this all the way over here in W. The most common mistake is, let me move this over, is that because you can't see W when you move this spreadsheet over, a lot of people will leave that W off. There's V, you don't even have V or W there. 2 columns will be left off, so make sure you realize this is going to be, what is this? L4, so when you're running these equations, your L4 ... through whatever the bottom right hand corner is. What is that? W10. I think, is that 10? Yeah. So you gotta make sure you're using the right cell location. But here you're giving me like a cell equation for the mean. Here you're gonna give me, there's a couple different ways to solve this one for the largest number in the data. This one's the smallest number in the data. Then down here, you're gonna give me the range between the smallest and largest. You're gonna create class ranges. You're gonna, all these question marks you're turning into numbers. For each class range here, there's 6 of them. You're then, once you change those, they change automatically down here and automatically. You're only working in the highlights. Don't change these cells that I don't have highlighted down here. I put formulas in here that will automatically copy whatever you type up here. Also over here, I have a formula in here I will talk about on Thursday. We'll help you make sure you're doing this right. Here, where's my equations here? Is this it? Right here. This is where all the points are for this week's homework. Let me say it again. Row 30. Row 30 will make or break this homework assignment. This is what the row you have to focus on this week that's due next on Thursday is row 30. You're writing 6 equations here in these 6 highlighted boxes, and when you get done, you'll know if you got it right or wrong based on what that number turns out to be. Don't change that formula, and I'm going to tell you on Thursday what that number has to be, and you'll know if you did it right or not. That's your little check and balance here. And then you move down here, and let's see, what do we have here? Oh, either you can change the numbers you calculated up here into relative frequencies or percent frequencies. So you're making frequencies here, and you can do one or the other. Some of you can do percent, some of you can do relative frequency, whatever you feel more comfortable with, and if some of you go for the gold and do both. It's up to you. But I have the word or there on all 6 of them, so you know you don't have to do both. You can do one or the other for each of them. All right, everybody understand what's due? The problems from the book and this Excel spreadsheet are all due a week from today. Everybody see it? Thursday, I'm sorry, I keep saying Thursday. Tuesday of next week is where you are going to learn the details to make sure you do this spreadsheet correctly. That's going to be the big part of Tuesday's lecture. Now, let's get into some of this boring stuff. Qualitative versus quantitative data. Here's the deal. Qualitative data is usually words and categories and male, female, dog, cat, blue car, red car, yellow car, something like that. But sometimes the words are switched to numbers. Like there's an example on this PowerPoint I think we're about to see where let's say you're having to call random people around town, around a community, and randomly selected, and you have to ask them, do you have a dog, or do you have a cat, or do you have both? And then you got to convert their reply to either a 1, they have a dog, a 2, they have a cat, 3, they have both, 4, they have neither. And so it's still qualitative data because all you did was take the words cat, dog, both, turn them into numbers. Now, quantitative data will always be numbers, nothing but numbers. Let me repeat that. Quantitative data is always data that are in number format. They're numbers. No other way to have quantitative data but numbers. It's the qualitative, the left-hand one, qualitative data, that sometimes you gotta look at and go, wait, these are numbers, but the numbers represent words. If the numbers are representing words, it's qualitative. And if the data are words, it's qualitative. Now, with that said, let me jump to something here. Oh, come on. Oh, no. Hang on. There. We collected this data from the hotel. We did a survey. Did we collect quantitative or qualitative data?
Qualitative.
Oh, I heard some quantitative and I heard some qualitative, but I think I heard more qualitative. Is that correct?
Qualitative, yeah.
It is qualitative because they're all words. Now we may switch those to numbers. We may give, how many words are there? 5 up there? Let's start with the excellent, and then there's what's the next one after excellent? Above average, average. Is there a below average? Below average, 4. So there are 5. We could give them a 1, 2, 3, 4, 5 and assign them numbers, but even if we do that, we're still collecting qualitative data because the numbers represent words. That's how you recognize qualitative versus quantitative. All right. Now, I jumped ahead. Let me go back here. Going to 22. This is cross-sectional data. Okay? Look at all our subjects today, by the way. We're doing cross-sectional data. Where's, I didn't even put it up there. Qualitative versus quantitative. Cross-sectional data. What you need to remember about cross-sectional data is being able to tell the difference between it and time series data. Here's the key with cross-sectional. You're collecting data from the same point in time. That's the key. You're collecting data, but all the data you're collecting is coming from the same point in time. This example says we're collecting building permits from all these different counties, but we're collecting them all from June of 2007. Notice that's the same period of time, June of 2007, no matter which county we go to collect this data at, it's the same point in time. That's what makes it cross-sectional. Time series data is the opposite. It's not the same point in time. It's a series of times. That's why it's called time series, because it's from a series of time intervals. Again, we're collecting building permits. We're only collecting from one county in this example, but we're collecting how many from 36 different months of time. For the last 36 months, we're getting the number of building permits for each one of those. So we're collecting 36 pieces of data, but from different points of time. That's what makes it time series. But you can tell the difference, right? Time series, cross-sectional. I should have put up verses right here, because if you have a question coming up, either on the final or the quiz 2, it's probably about you recognizing whether that's cross-sectional or is that time series. That's probably how you would prepare for that. All right. We also need to know the difference between experimental studies and observational studies. This is a big deal because some of you, whether you realize it yet or not, you're gonna end up going out after a graduate degree. Some of you already know you're gonna, and some of you aren't gonna realize it until you get into your careers. And you go, wow, look at the money I can make if I go back and get my grad degree while I'm working full time. And when you do that, most, not every grad degree, but a huge percent of grad degrees have this ending part of it called a thesis, where you have to prove you understand how to apply statistics to data that you gathered, either through experimental study or observational study. Experimental or observational. Now, most of my people were going to grad school with did observational studies, including myself, where they did like surveys. Whatever there was, they were trying to prove, hey, the morale here is low. They put together a questionnaire, and when you learn how to do a thesis or do research, you learn how to design this questionnaire so there's at least 2 questions asking the same thing 2 different ways, so you're getting really true responses that way, you know. It's all this stuff is involved when you're doing research, and that's what when you get a master's thesis. And by the way, a doctoral degree is doing what's called a dissertation, which is a thesis times 10, where you got to do the whole big shebang. With a master's thesis, you're just proving you can do research. You just do a mini research project. And so observational is usually doing surveys or questionnaires to collect the data. You're collecting opinions. People may be circling a range from 1 to 5 of whether they strongly agree or strongly disagree or something like that. That's called collecting observational data. Experimental data is very different. I like to use the example of the COVID vaccines because University of Michigan Ann Arbor was involved in some of the research before the vaccines got approved. And experimental research is where you have like a placebo involved, and you have 2 randomly selected groups doing the exact same thing, but receiving 2 different things that you want to compare to each other, or something's different about them. Matter of fact, let me give you even with using humans, an experiment can be done. You ready? One experiment a colleague did is where she said, I'm going to have 30 professors record themselves for a lecture. And then she counted how many times she heard some kind of hesitation in the speech where the professor used the word or one of those common words that drive people crazy if someone says it over and over again when they're in between sentences. And then she had those 30 professors go to a training program to point out how to stop using all the time between sentences, or you know what I mean, or you know what I mean 100 times, or whatever, stopping that stuff. And then all the 30 professors had to go back and record a lecture again after the training. And the whole thing is, this is called a before and after experiment. And if the amount of and whatever they said have decreased significantly, it proves then that that training caused it. But if the number of ums and things didn't decrease significantly, then it doesn't prove the training caused it. That's an experimental study. There was a before and after involved with a training in the middle. And again, like I said with vaccines, you have a placebo and a real vaccine, and you measure everything about the two groups. And you have to, and when you do experimental studies, or even observational studies, for you to prove your point, for you to prove whatever it is you decide you're trying to prove, you gotta be off the chart. If everything was normal, your data's gonna show up somewhere in here, and you didn't prove anything. But what you're trying to prove is so far out here that the data has to be way out here to prove you're correct. And that's what I mean about the COVID vaccine. It would never be approved for humans unless it was proven way over here or here that it was the item that was affecting the group that was truly taking the vaccine compared to the group that was not, that was just taking salt water, saline solution. The only way you could get these results is so far different than the results from those taking saline solution, so far off the chart different, that it has to be the vaccine that's causing this a positive effect, whatever that may be. That's how research is done. And if it's anywhere close to here, that maybe the vaccine's doing something, never get approved. Never. It has to be off the chart. That's how research is done. It's gotta be, when it's something like a vaccine, it's not gonna be in the 1%, 1% to the right, 99% to the left. It's gonna be in like the half of 1% or quarter 1%. That's how proven the data has to be to get approval to allow humans to use it. Now, I know a lot of people don't like regulation, but it protects us. It protects us from something like awfulness could happen. Anyway, the point I'm trying to make is that's the difference between experimental and observational. And you have to learn how to be able to do the calculations to see if your data's out here in the tail. Because if it's out in the tail, you proved it. Anybody work at like a cell phone store in their lives, you know, selling T-Mobile plans or M-Mobile, so you know what I'm talking, okay, you ready? You're at the T-Mobile place and you go, look at how many customers we have in this, on our system here. Let's say we have, you've signed contracts, you have contracts going with 1,000 customers. Let's randomly, you say to an employee, I bet you if we randomly select 40 of our customers, that the average cell phone bill is gonna be $40 or more. And the other person says, no way, everyone's cell phone bill is less than $40. All right, I'm gonna say less than $40, you guys make a bet. But here's the deal, you're gonna get them and here's $40. For you to prove that everyone's cell phone bill is more than $40, the average has gotta be way up here. Or for the other person to say, no, you're off, there's no way $40 is significantly less, it's gotta be way down here, this is 40. You gotta be so up here and so down here in research, you would have had to grab those 40, and that number would have had to be so far above 40 for you to win the bet, that's how research is done, that you would have to find that, oh my God, people are paying $60. I thought it was 40, they're paying $60. Or for the colleague to be right, you're not gonna grab 40 of them, and what I say this is 40, and oh, it came out to 30, you didn't prove you're right. Randomness could have caused it to be 30. Your 40 that you randomly select, their average cell phone bill has to be like $19 when you, that proves then it's under 40. That's how far off the chart that research has to be when you're doing your master's thesis to prove something. It has to be way away from what was expected. We think the average cell phone bill is $40, and we're trying to prove that no, it's much more, or no, it's much less. Well, for you to prove it, it's gotta be really more or less to prove your point with a sample of 40. Everybody get it? That's research. That's what's going on. That's the difference between experimental and observational. All right, couple more things. We're going to chapter 2's PowerPoint. These are gonna be easy things. We gotta review, get ready for the written part of today's homework. We gotta take this data now, and we gotta turn it into a frequency distribution. So if you were given raw data, and you return it to frequency distribution, take the words and put them in order. Excellent, above average, average, below average, poor, and then count how many you have of each one. There it is. That's a frequency chart. Now, on your homework, you're given the frequency chart already. If I said to you, I'm going off the cuff here, how many how many would you say said below average or worse? Was there a stay at our hotel? How many said below average or worse? What are you adding up? Give me what you're doing in your mind.
The poor and
3 and what else? 2. So total of 5. That's how easy that first problem is on your homework. It's asking you a question. Just tell me which numbers you're adding up and what the total is. How many would you say said they had an average stay or better? What numbers are you using?
5,
9, 1, add up to 15. You get it. All right. You got it. Now, turning these into relative frequency, which is problem number 2. You remember how to do this? This is kind of review. You got to take each one of the individual counts of frequencies divided by the total number of frequencies you have. So 2 divided by 20, 3 divided by 20, 5 divided by 20, 9 divided by 20. Leave it in decimal form. Hang on, come on that left-hand side there, and you've now made a relative frequency chart. Don't move the decimals 2 places to the right, or you've turned it into a percent frequency chart. I want to make sure you realize that. That second homework problem from the book is asking for relative frequency, not percent, I think. I'm pretty sure. So you want to do it like that, the left-hand one. Got it? Everybody know how to do the second homework problem? This is almost too easy, isn't it? Don't give me the 10 minutes when you get in here Thursday next week. You'll put me in depression. Now, the next step is where you're given the relative frequency, but look, how many were there total there? Hang on, I gotta go back and look. 20, right? You're given the relative frequency, 10%, 0.10, 0.15, 0.25, and you know there were 20 respondents. Show me the math to convert each one of those relative frequencies back to frequencies. That's problem number 5. And then answer the question. I think number 3 has a question after you do your work and turn it into relative. Number 5 has a question after you convert these, okay? Do your conversion, show me the new table, and then answer the question. They're easy. What? 0.10 times 20, 0.15 times 20. There, I did 2 over for you. All right? How do we feel? The written assignment, too easy, right? We good? All right.
You said times 20?
Now, I'm sorry, say it again.
You said times 20 or divided by 20?
I don't know, take, what's 20 times 0.10? What do you get? Let me go back to the frequency. Do you get 2? Yeah, I
Yeah.
get 2, see? Yeah, you times it. Right? You get the total, yeah. Look, I gave it away. I couldn't even hide it. All right, this is a bar graph. I know you guys can read bar graphs. I'm gonna, hang on. What's the most common reply we got from this survey? Okay, I know you can read bar graphs. What you need to know about this bar graph is what's the difference between it and a histogram.
Histogram has no gaps between.
No, say it again, histogram what?
A histogram has no gaps in between.
That's right. How did you know that?
Statistician.
Stop it. Stop. Hang on, I'm gonna see who you're fooling. They must be behind me. All right, let me show you the histogram. Come on, come on. There's the histogram. It looks just like a bar graph, but it doesn't have the spaces between them. All right, they're all touch each other. It's still know the difference between the two. Hey, is that a bar graph, that histogram? And then answer this question. What is the most common cost of parts for these, this was tune-ups. What's the most common cost of parts for tune-up? Between what and what price?
70 and 79.
Yeah, you can read these. Okay, you know the difference between a bar graph and histogram, right? Let's go to now, come on, 11. Hang on, gotta go to 11. There we go, pie chart. Let me just show it. There it is. You can all read pie charts. The percentages that gotta add up to 100%. If I said to you, what was the second most common reply to the survey according to this pie chart?
Average.
Poor, wasn't it?
What?
Average.
Average.
Second. I said second, least common?
You said second
Did I say most
most
common?
Yeah.
Well, I swear in my head I was saying least common. Really? Most common I said? Darn. Don't get old. Just saying. Average. Is it average or above average?
Average.
Average, okay. Everyone can read this. You can probably make one, right? What's the sliver? What does that represent?
Sliver?
The sliver. Sliver's always the smallest little part of the pie.
Excellent.
Excellent, that's right. Excellent. You guys never heard the word sliver? No. Oh my gosh. That must be a generation thing. All right, last one. Not the last one, but almost last one. Hang on, I gotta find it. It's called the dot plot. Come on, there it is. The only reason I like dot plots is in the old days, before we had even computers, this is going back a long ways, we could easily find the mode by using a dot plot. Because you're just reading, someone's just reading the numbers, you're just putting the dots on the line, and then whoever has the highest stack is your mode. So what's the mode of this data?
63.
Is that 61,
62.
I don't think 63, that's a tough one though.
62.
62-ish maybe, yeah. That's the tallest one. That's how you find the mode. That's what a dot plot's really handy for. So I guess the question would say, what would be the most common handy thing to use a dot plot for? To find the mode. Okay? Okay, now I thought we might have a little bit of time, so I want to prepare you for real life. Just a little bit of a career thing here, right? Most of my career was in management positions, and the worst part of being a manager are the employees. I'm sorry to tell you this. It's the truth. It's the worst. You get the promotion, and you can't, you're going, oh wow, I can't wait to tell my parents I'm a manager now, and look at the raise I got, and oh my God. And then you let a few months go by and you go, oh wow, I miss my old job. I can't believe I gotta deal with all these people and all their problems. Oh my God, everybody wants every day off. How can I get this schedule ever to work? Blah, 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 right? Here's the deal. What I've learned from working with a lot of other managers is that you think as an employee that the way to get promotion or the way to get that extra pay or to get those additional responsibilities is to be great at your job. And that is important. That is important. But I am shocked at what is really almost just as important, for some managers more important, and that's the employee's attitude. I can't believe it. Attitude on the job is so important. As important as your skills. That is possible, someone with slightly less skills than someone with the most skills, if they have a better attitude, is getting the promotion, is getting the new responsibility, is the person we're putting to this new location to run the department or something like that. Attitude. And let me be more specific with my advice, and I've heard this too many times in my life. Never, ever, 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 ever let the words come out of your mouth that say, that's not my job. Don't ever let those words come out of your mouth. Don't ever say, that's not my job. If you are getting paid thousands of dollars, be a team player. And if you want to get up into management yourself, be the team player. And take it easy on your manager, because that's the hardest thing for them, is to manage other humans. I'm telling you, it's not worth the extra money, actually. That's all I got. I'll see you guys next week. Have a great weekend.